What's up, Nishit Tarantula? There's a big question in people's mind of why acceleration and gravitation affects the time. Consider a man in a box. Suppose the box starts moving towards the ground. What will the man feel? The man will feel that he is weightless, or the gravitation acting upon him is actually decreased. Or if the box starts moving upwards, what will the man feel? He'll feel that his weight is actually increased and the gravitation acting upon him is increased. It was said by Albert Einstein in his theory of general relativity in 1915. So how time is affected by this phenomena? Take a rocket at rest in space. There are two persons in the rocket, A and B. A is standing at the top of the rocket and B is standing at the bottom of the rocket. And A is sending light pulses towards B. For sake of simplicity, take the time as 1 second. That means the length of the rocket is highly incredible, that is 300 million meters. But for sake of simplicity, take it as D, and take the time taken by the light pulses to reach B as 1 second. So, A and B both have a clock with them. Clocks with them, and clock ticks every 1 second as the light pulses reaches towards B. Everything will be normal till the time rocket will be at rest. But when the rocket will gain a speed, or it'll start accelerating upwards, what will the observers feel? I taught you relativity. You'll be knowing what they'll feel. Obviously, they'll feel that the gravitational force is acting upon them, and they are pulled by the gravitation towards the ground, or towards the bottom of the rocket. So, what is causing the time to slow down here? Suppose this finger is B, and this finger is light pulses. I said that rocket is in motion. That means B is also in motion along with the rocket at the same speed at what the rocket is. So the B is moving upwards, and the light is moving downwards. Do you observe that? When I move this fingers upward and this finger downwards, so the time taken by both the fingers to touch each other decrease as it was before. Yeah, it's pretty interesting, and that's happening same in this phenomena. Now let's do the opposite of this. Suppose now B started sending light pulses towards A. What will happen? Obviously the rocket's in motion, then both A and B will feel gravitational force acting upon them. But something will be pretty more interesting, that will take more time to reach A as compared to the time taken by light to reach B. You know why? You'll be knowing why. Because A is moving along with the rocket at the same speed at which the rocket is moving. The light pulses will chase A. Suppose it's A, and these are the light pulses sent by B. A is moving along with the rocket, and light is chasing A. And that's why the time taken by light will be pretty more as it was before. You might be thinking that, what is happening? The distance between A and B are still same. So what is happening? Is the speed of light changing? Well, I'll say really no, because the speed of light is constant, which is 300 million meters per second. But something have to change, and that's the time which is changing. This is even same on Earth, because Earth also exerts a gravitational pull towards every object which is near to it. And when the rocket started gaining a speed, it started exerting a gravitational pull, or all the observers inside the rocket felt a gravitational pull, which is pulling them towards the bottom of the rocket. But Earth also exerts a gravitational pull, because it curves the space-time. So, time not only stops in space, it also stops in or slows down on Earth. I can tell you how. The same way, I kept this clock here. This clock is pretty closer to the center of the Earth, but it's pretty far from the center of the Earth as it was before. So what is happening is that when I make this clock come towards the center of the earth, pretty more closer, this clock starts moving slower. Yeah, you'll not observe this. Every time you'll feel that everything is just normal, but it's just a very small scale. It's on a very small scale. So but actually what's happening is that the time for this clock is actually slowing down as it moves towards the center, and it just increases as it moves farther away. And that's how the time slows down, or time is affected by the gravitation. Thank you. Bye.